Predictability is paramount. Then we have periodic scheduling. This is perhaps the most common type you'll encounter in web development. With periodic scheduling, tasks run at fixed, recurring intervals. You might schedule a task to run every hour, every Monday morning, or once a day. This is perfect for things like refreshing cache data or sending daily digests. Finally, there's event-driven scheduling. In this model, tasks aren't tied to a specific time or a batch. Instead, they are triggered by specific events. For example, when a new user signs up, an event fires, triggering a task to send a welcome email. This approach is highly reactive and often used in microservices architectures. Each has its strengths and weaknesses, and often a complex system will utilize a combination of these approaches. Now, let's consider some of the challenges you might face when building or integrating these systems. Building or integrating a task scheduling system isn't always straightforward. There are several significant challenges and considerations you need to keep in mind to ensure your system is robust and reliable. Process. One of the primary concerns is concurrency and parallelism. In a modern application, you're rarely running just one task at a time. You'll likely have many tasks needing to execute simultaneously. How do you manage these without them interfering with each other or overwhelming your system resources? This involves careful design for parallel execution. Closely related is scalability. As your application grows, the number of tasks will inevitably increase. Can your system handle this growth gracefully? Can you easily add more worker processes or resources to cope with a higher task load without redesigning everything? A well-designed scheduler should scale horizontally. Another critical consideration is fault tolerance. What happens if a worker process crashes in the middle of a task, or if the server hosting your scheduler goes down? A robust system needs mechanisms to detect failures, retry failed tasks, or ensure tasks complete successfully even in the face of component failures. Finally, and often overlooked, is monitoring and logging.